Good morning, ladies and gentlemen. My name is Chen and come from Xijing Hospital, China. My topic is plasma exosomal miR-375-3p regulates keratinocyte ferroptosis by targeting GPX4 in SJS. In relation to this presentation, I declare that there are no conflicts of interest. Stevens-Johnson syndrome and toxic epidermal necrolysis are life-threatening adverse drug reactions and characterized by widespread epidermal damage caused by keratinocyte death. Ferroptosis is a regulated cell death driven by lipid-based reactive oxygen species accumulation. Exosome and nanometer cell vehicles with a lipid barrier membrane contain functional proteins, DNA, miR, and microRNAs, which enable them to operate as signal platforms for delivering information to other cells. Exosomes are also present in various body fluids, including plasma, saliva, and urine, where they can cause immune dysfunction and influence disease progress. So we have a hypothesis that plasma-derived exosomes induce keratinocyte ferroptosis in Stevens-Johnson and TN patients by delivering microRNA signals to the skin. The exosome miR-RNA research strategies including four aspects: exosome isolation and characterization, exosome microRNA profiles, and the function of microRNA in target cells, and the mechanism of microRNA in target cells. The first, the exosome isolation and characterization. We utilize autocentrifugation to isolate exosomes from plasma of SLT patients. We uncovered that the exosome isolate from plasma of Stevens-Johnson TN patients show that the cup-shaped exosome vehicles Westblot indicated that the exosomes were predictive for CD9, CD3, and TS111. Then the average particle size were lying within expected 30 to 200 nanometers range. The second, exosome labeling and internalization. We label the exosome with DRI and incubate them with target cell for 24 hours. After that time, the exosomes were mostly internalized. We further investigated whether plasma-derived exosomes affect keratinocyte ferroptosis. We measured the MDA, error accumulation, TSH level, and lipid peroxidation. The results show that T exosome increased the MDA and error accumulation to a higher level than either EM exosome or control exosome. The T exosome exposure also significantly reduced TSH level. Westblot assay showed that T exosome also significantly induced ferroptosis by upregulating GOT1, ACF4, SLC1A4, and by downregulating GPX4 in keratinocytes. Cells subject to T exosome produced considerably more ROS than those exposed to EM exosome or control exosome. For the first time here, we established that the human keratinocytes internalize T exosome, which strongly promotes ferroptosis. The three exosome microRNA expression profile in drug eruption. The microarrays evaluated that there were 240 upregulated and 111 downregulated microarrays between the T exosome and the control exosome groups, and 28 upregulated and 22 downregulated microarrays between the T exosome and the EM exosome groups. Then the miR-375-3p was marked upregulated in TN exosome relative to the other groups. Therefore, we used the miR-375-3p in subsequent investigations. Therefore, the function of miR-375-3p in keratinocytes. The miR-375-3p overexpression in keratinocytes elevates intracellular error, MD accumulation, and lipid RS, and reduce GSH level. Then the miR-375 mimic significantly upregulates the ferroptosis modulators GOT1, ACSF4, SLC1A4, and downregulate GPX4 in keratinocytes. In situ hybridization showed that the miR-375-3p signals were more evident in the epidermal tissues of SJS patients than in those of healthy controls. For the mechanism of miR-375-3p in keratinocytes, we applied the target scan, miR-RGB, miR-work, and miR-tar-base, and the key Xijing pathway to predict miR-375-3p target genes. The GPX4 activity maintains intracellular lipid homeostasis, prevents the accumulation of toxic lipid ROS, and blocks onset of ferroptosis. The first, where GPX4 was downregulated in keratinocytes over increasing miR-375-3p. Furthermore, the miR-375 mimics reduced luciferase activity in the wild type but not the mutated construct. Therefore, the miR-375 binds to the GPX4 5-UTR and directly regulates GPX4 expression. Ferroptosis of miR-375-3p on primary keratinocytes were partially counteracted in the GPX4 overexpression group by intracellular iron MD accumulation and lipid RSAC. The results evaluate that ROS scan inhibitors significantly inhibit ferroptosis in keratinocytes after TN exosome treatment. The circulating exosomal miR-375-3p levels are positively correlated with BSA scorton CRP in SNT patients. Summary: we hypothesize that the circulating exosomal miR-375-3p entered keratinocytes, substantially downregulates GPX4, induce MDA, iron accumulation, and lipid peroxidation, and ultimately promotes keratinocyte ferroptosis in SLT patients. Conclusion: first, the circulating exosomal miR-375-3p were elevated in SLT patients. Second, the circulating exosomal miR-375-3p entered keratinocytes, downregulated GPX4, and induced ferroptosis in SLT patients. The third, the plasma-derived exosomal miR-375-3p levels are positively correlated with clinical severity in SLT patients. Acknowledgement: this work was sponsored by National Natural Science Foundation of China. Thank you for listening, and thank you very much.